Hey everyone, this is Homework1 and I'm down the page. The first question in give the state diagram for a DFA that recognize W, E, A, B. W is E or starts with B or starts with AB. Over the alphabet, E equal to the parenthesis AB, and the solution is the question 1. Yes, I'm to solve it, and today we are diving into the fascinating world of automata theory. Specifically, we are tackling a question about deterministic finite automata, or short DFA. Now that might sound like a mouthful, but trust me, it is not scary as it sounds. So, our first task to create a DFA that recognizes the language. I am explaining that the upside down, and now, before we jump in, let's make sure we are on the same page. What does it mean? Basically, our DFA needs to accept three things. The empathy string, which we can all agree is a classic. Any string that starts with AB because why not? And any string that begins with AB. Sounds fancy, right? And first, we need a start state. Let's call it Q0. And this is our cozy little home base where we can safely say, welcome, you are in the land the automata of, and by the way, Q0 will accept the empty string. Yep, it is all good here. And next, let's talk about the transition. From our start state Q0, if receive AB, we transition to a new state Q1. This state is like that friend who's super child and loves to hang out. In string starting with B is totally welcome here. Now, if we receive in A, we head over the state Q2, but hold your horses. For Q2 to let us hang around, we need to bring another B into the mix. That means we transition to state Q1. If gets another B, it's like a part inversion. And final states. Yes, these final states, both Q0 and Q1 are accepted states. So if we land in either of these states, we are good to go. In conclusion, our DFA is super inclusive, accepting strings that are either empty, starts with B, or starts with AB. It's like a club where everyone's invited as long as they follow a dress code of starting with AB or AB. So, remember folks, DFAs can be friendly gatekeepers to land use, ensuring only the right strings get in. Let's keep that automata party going. And the next page is question 2. Is question 2 describe the language represented by the automata below, specify exactly what set of strings in accept. Briefly explain why to the FA accept this set of strings, and A, B, C, yes. And next, keeping the solution. Question 2 solution is right. Yes, this is mathematically explained. All right, moving on to our second question. This time we got an existing DFA that we need to analyze and describe the language it represents. Yes, I'm again skip to question 2. Yes. Now, this DFA has three states. We start at state A or Charming Coast. From state A, we can go to state B if we read an A, or we can head to state C if we encounter AB. Let's break it down. From state A, if we read an A, we happily dance to state B. No one judging, it's a party. If we read AB, we take quick step to state C because variety is the space of life, right? Now we happens in state B and C. In state B, if we read another A, we are still in state B. It's like the dance floor getting crowded with a lot of AS. But if we read AB, we will transition to state C. Oh, the dance might be getting messy. In the state C, if we read another B, we state C. More B as more fun. If we read an A, we go back to state B. It is like a never-ending dance-off between A and B. So, the language represented by this DFA consists of strings that can have any combination of AS and BS, but they must alternate of starting with either A or B. It is a bit like a dance battle where you can keep the same moves for too long. In summary, our language can be expressed as L equal to V in AB starting. Yes. No. This, yes. Stars and W not equal to E and W not equal to L. It is L is empty string. And let's keep growing. I go to the question 3 easily. I'm reading the question 3. Let E A B and let L W. W is not A or B and does not contain the subtraining AB. Give the state diagram for a DFA that recognizes L. And the solution, I'm going to question 3. Yes, this is the solution. And finally, here we are at the last question, not last question, but it is the last question, same thing. We are tasked with creating a DFA for the launch LV meet V text. It's not a text or be a text. And now this sounds a bit tricky, but we are up the challenge. Starting state, we begin with our friendly state Q0. This is the place where we can hang out and have a good time. This state will accept empty strings and any string that don't straight start with A or B. Transition, if we get an A, we move to the state Q1. But here's the catch. We need to be careful because if we see A, B next, we were in big trouble. That will create the subtracting AB, which we want to avoid at all costs. If we see AB, we move to state Q0. Again, we must be coitus. Seeing an A here would also lead us to the dreaded AB. Final state, the accepting state will be Q0, and any state that only receives A's or B's without forming AB. So if you avoid AB, you are good to go. So our DFA will gladly accept strings like A, or B, or even the empty string, but will firmly reject strings like AB or any strings containing AB. In Essence, these DFAs like strict bouncer at a club, checking IDs to ensure no ABS next in. So let's remember, DFAs are not just about recognizing patterns, but also about enforcing rules to keep the things in order. And I'm skip the fourth one. Yes. This is the FA graph, and I'm reading the text. Describe the launch represented by the automata below. Specify exactly what set of strings it accepts. Briefly explain why the DFA accepts this set of strings. And your analysis of the DFA's truth and accord. Here's a summary. These DFA general properties of DFA states. There are 6 states. 1, 2, 3, 4, 5, and 6. Yes. And start state. State 1 is the initial state, except state. State no. 6 is the accepting state, represented with a double circle. And state 1. On input 0, it is transition to state 2. On input 1, it loops back to itself, state 1. And state 2 is on input 0, it transition to async rejection state. And input 1, it is transition to state 3. And state 3 on input 0, it transition to state 4. On input 1, it loops back to state 2. State 4 on input 0, it loops back to itself, state 4. On input 1, transition to state 5. State 5 on input 0, it transitions to state 6, the accepting state. On input 1, it loops back to state 3. State 6, it loops back to the itself, state 6 on both 0 and 1. Launch accepted by the DFA. The DFA accepts strings composed of a specific sequence of first or 0 to reach the accepting state. It is state 6. We need to follow a particular transition sequence. Reaching the accept state. To reach the accepting state, we need to follow the sequence. Input 0, state 1 to go 2, input 1, state 2, go to state 3, input 0, state 3, go to the state 4, input 1, state 4, go to the state 5, input 0, state 5, go to the state 6. Additional characters in accepted state. Once in state 6, any additional 0 or 1 will also be accepted as there allows returning to state 6. Example accepted strings. Accepted strings is example. Maybe 0, 1, 0, 1, 0 or 0, 1, 0, 1, 0, 0 or 0, 1, 0, 1, 0, 1. And so on. These strings start with 0, 1, 0, 1, 0, 1 and can be followed by any number of 0 and 1. Why these strings are accepted? The DFA records the input to contain specific sequence 0, 1, 0, 1, 0 to reach to accepting state. Once this sequence is completed, any subsequent 0 or 1 can be added since the DFA remains in the accepting state. Yes, this is solution in the mathematical formula. And skip the question 5. I'm reading the question 1. Give the state diagram for an NFA that recognize V A B star V contains at last one one instance of BABAB or ABBB or BBBBB. Yes, I'm solved it, but I'm not sure it's correct. But I'm explaining that the question 5. We are going to design non-deterministic finite automaton or NFA for the short date recognized specific language. So buckle up. The launch we are looking at LWAB star and explain that before the remaining. In the plane, the means want to accept any string includes at least one this there substring. Now let's break this down step by step because we want to make this fun possible. Step 1, understanding the language. First up, let's analyze what we need. We need to create different pathways in our NFA for each substring we want to recognize. So we are going to set up 3 separate paths. It's like throwing a party and having 3 different rooms for our substring. For BABAB, we will start at state Q0 or first B, then we move to Q1 for A, Q2 for the second B, Q3 for the second A, and finally Q4 for the last B. When we hit the Q4, we will celebrate because we just accepted B, A, B, A, B. And for A, B, 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 starting from the new state, let's call it the P0, and I'm explain Q0 and equal to P0 I'm thinking and then it is of the P1 for the first B, P2 for the second B, and P3 for the third B. Hit P3 and we have got another victory dance for ABBB. And for BBB, here we start state R0 and again I'm thinking the Q0 is equal to R0 and then it is a straight shot through R1, R2, R3 and finally R4 with that fifth B, another big celebration when we reach R4. And step 2, states and transition. Now let's talk about how to move from one state another like a game. Hopscotch with our input characters. Starting state. We can set Q0 as our starting point. It's the hub of our automaton where all the fun begins. Transition from Q0, if we see AB, we can go to Q1 for B, A, B, A, B, or R0 for B, 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 B. If we see an A, we can go to P0 for A, B, B, B. From Q1, we transition Q. Yes, 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 B, Q, R, Q, Q1 and R1 is equal. I'm changing it, but yes. And so on, following the structure with step at is substring. Now here comes to exciting part. We need to decide where our automaton will accept string. We are set up the 3 happy ending. Accepting state Q for B, A, B, A, B, P3 for A, B, 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 R for B, 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 B. If we reach any these states while processing or input string, we will do a little victory dance and accept the string. And driving the NFA, to Vigilus or NFA. Q0 go to P0, Q1, Q2, P0, P1, R0, R1, Q2 go to Q3, P1 go to P2, R1 go to R2, Q3, R1, Q4, P2 go on P3, and R2 go on R3. R3. It seems Turkish. I'm sorry. R3 go on R4. Yes, it is driving, but Q1 and R1 is same that, and a bit is wrong. But yes, it's true one, but same that false one. Thank you listening and watching, and see you next videos.